All right, we're in day 2 of chapter 7. We just talked about exponential growth and decay, which was, oh goodness gracious, still learning this new camera. Everything's backwards. Okay, let's just roll with it. So we're talking about compound interest, and it arises when interest is added to the principal. So from that moment on, the interest that has been added also earns interest off of that. Seems isn't very fair, is it? So when we think compound interest, we think college debt, credit card debt, or you're making money with stocks, things like that. You're making money off of money you made. So we tend to think if you don't pay 100% of your payment off, so like say you had $100, like a bill that was billed to you and you only paid part of it, then that interest you received on it gets not taxed, but a percent increase again. So you're owing more money on money that you owed. So compound interest is very tricky. It's not like simple interest. The total amount of investment. So say you're investing money, that's a great way to get interest. Okay. It's your principal, one for your multiplier, whatever that rate is. Say it's like 80%. Then it's divided by how many times that 80% has been hit to your account. So N is the number of times the compound interest happens a year. So you have a credit card payment, that's monthly. So that 80% would be divided by 12, but hit to your account 12 times a year. And T is the number of time in years. Okay. So this could be for a variety of things, not just a credit card or loans, things like that. All right. It says find the final amount of a $500 investment after 8 years at 7% interest compounded annually, quarterly, monthly, and daily. So we have $500 and we have a few different scenarios. We're going to have our 1 for our multiplier, and then we're going to have our rate of 7%. But that 7% is being divided and hit to the account differently. If it's annually, it's 1. If it's quarterly, it's 4. If it's monthly, it's 12. And if it's daily, we're just going to go with 365. And then T is the time in years. So they're all 8 years. Is there going to be a difference? Okay. What are the difference amounts? Okay, now let me look real quick and find what those amounts are before I have to type them all in the calculator. Now, I'm going to tell you what these answers are, but I really want you to go into your calculator and see if you can just do at least one of them. You're going to get $859. You're going to get $871.11. You're going to get 8,000 or 873.91, 8,000, and 875.96. Now, these aren't significant differences. Okay. They aren't huge, but you'll see the more times it's compounded, the more interest money you're making off that interest. Okay. Effective yield is the annually compounded interest rate that yields the final amount of investment. Okay. So, for instance, we have, it says a collector buys an antique stove for $500 at the beginning of 1990 and sells it for $875. So we started with $500. Okay. And at the end, it's going to be worth $875. We don't know what the rate is or the effective yield, But we know that from 1990 to 1998, that's 8 years. So T is time in 8 years. It says use the exponential regression equation to find the effective yield. Well, it didn't say anything about being compounded, so we're going to assume it's 1. So this is going to be 875 equals 500, 1 plus r to the 8th. We're going to divide both sides by 500, and 1 plus r to the 8th. Okay? You're going to have to take the 8th root of both sides. And so the 8th root of 875 over 500 is going to equal 1 plus r. Then you're going to subtract 1. And what would that be? So you're going to go ahead, use your calculator, and say, okay, go to 8 for the 8th root, math button, use that star of 875 divided by 500, and then minus 1. So that's 0.0724. That's about 7.25%. Okay, and that's how you can figure out with loans, with cars, with things like that. Okay, you work backwards. It says find the effective yield for a painting bought for $100,000 at the end of 1994 and sold for $200,000. So you bought it for $100,000 and then sold it for $200,000 at the end of 1994. So that'd be 10 years that went by. So we're going to assume it's not talking about compound. Okay. It's not talking about compound. So we could try it again like this. 1 plus r over 1, 1. So 100,000 being divided. And then it's 1 plus r to the 10th. So you end up getting 2. Take the 10th root. And then subtract 1. And that should give you r. Okay. So we go here. 10th root. Okay. I don't know why I put 20 down here. It should be 2. So we get 0.71. So 0, 7, we're on to 2. To the right. It's about 7.2%. Okay. So that's how you find the effective yield or the rate. All right. So where does this actually come into play? How is it beneficial to you? So here's a piece of paper that I got from, it's called the Dave Ramsey Financial Peace. So like you, I was a 16-year-old that went to Girard. I didn't know anything about anything like this. That's why I'm so impressed when I hear your classmates talk about it. So I became an adult and I still didn't know a ton. And I went to this course that was talking about how to understand money and working with it. And I was fairly young, so it was helpful. And it's showing in this. Now this is about a 12% return from stocks and investments. So there's a guy, Ben, and there's a guy, Arthur. And when Ben is 19 years old, he has $2,000. He invests it when he's 19. When he's 20, he takes another $2,000 and invests it and does it every year until he's 26. So that's 7 years. 1, 2, 3, 4, 5, 6, 7. of $2,000. Wait, 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry, that's 8 years. Okay, so that's $16,000 he invested. When he's 27, he stopped. He just let it sit there. He didn't pull money out. He didn't say, oh, I want to go buy a house. Let me pull it out of my investment. He was patient. He waited. Then when he was 65, he was a millionaire. Arthur didn't invest when he was 19. And then at 26 years old, he's like, maybe I should start investing. He invested a ton of money, but he didn't let it sit. Time was not on his side and only got 1.5 million. So the moral of the story here is you guys are very lucky. You have time on your side. I'm down here. Luckily, I started investing right around between Arthur and Ben, around 23. Okay. And you just let it sit. It's not too late. So people are going, what's your advice? What should I do? Just start saving your money so you can be like Ben. And when you're 19, put $2,000 into your account. Okay. You let it sit. All right. This sheet you should have done on the first day as homework. Hopefully you should have done this one just to check yourself. And I have the notes filled out. You can always check it here. This is going to be your homework. Okay. Both these sheets. So this sheet's kind of obvious what you can do. We've talked about it. This sheet, you're going to start here. This is what y to the x looks like. Now you look down here, which one's going to be A? It's this graph, but you just minus 3. So I needed to go down 1, 2, 3. So which one has a graph that's kind of like here? No. Oh, this one looks like it. So this is A. And you're going to match those. You're going to take pictures of both these worksheets and submit it. And then here, I want you to do this word problem. You can check your answers that all notes are filled in on our classwork section. Okay. And then this next page is a lab. So you don't need to do this. If we were in class, we would do it. But we're not going to. But if we come back, we might have time to. Okay. And then we'll start this tomorrow.